Okay, so this is for F2, and the first one is draw everybody of the box. And so for in my original one, I only did just one, and I tried putting like all of them in it, which I also feel like kind of messed me up. And yeah, and so I got that mixed up too. And so the coefficient of kinetic friction is 0.2 instead. And so then that was my everybody for that one. And you can see like I did F net applied because I didn't really know what it was called, but now I know it's called F push, or like the way that the force is going like as you're pushing it. And so then there's force normal, and then there's gravity. And then I labeled where the frictions were going, but that was wrong, and I'm not explaining when I get to that. And then, well, one of them was wrong at least. And so that's what I have for my free body. But then in here, I did 3 separate ones, and I did this one with no push and no acceleration, like nothing at all. It's just force normal parallel to mg. And for this one, I did the kinetic one because as you can see in this one, I just had like friction in general. But this one, I was more specific in mine. I did static friction and then kinetic friction, but they're both the same thing. Well, not the same thing, but like they're in the same place because it's like friction all together. Like as I put in this one, but I just put it in 2 different ones. And then, then you have friction force. And I put the wrong equation for this one because I did kinetic instead of static when I should have done better. And I did the total together when it should have been static friction. And so it should have been static equals, not equals, but like is greater than, no, sorry. Static is less than static friction and then force normal. It should have been like that. And I thought it was 0.5 and times 20 because I was just kind of going off like here and the like force like applied, but I shouldn't have done that. And as you can see here, I did all 3. I should probably show it. I'll show it after. Okay, so I did the static friction, which is 0.4 times 100, and I got 40 in. And then this one, it was already in static friction form, and so I didn't have to do anything for that. And then for this one, I did the same thing I did up here. I just did, but instead I did the kinetic friction times force normal, and I got 20 in. And so now onto acceleration. I did all this because I didn't know that like it was already kind of you can like assume the acceleration, but because it stays like the same, and especially this one stays the same because it's 30 newtons and it also has a 30. Wait, no, I'm sorry. Yeah, 38. It's 38 newtons and it stays for 38. And so this one I did F net equals F net over the total force of friction over mg, when I shouldn't just have not done anything because they both have 0. These 2 top ones have a 0 acceleration, while this bottom one, I did this equation, the f of x equals F net minus the force of friction equals mag, when I should have done the f of x. I got that one right. Then f push minus f uf over m. And so I should have done this equation instead. And so I would have gotten 50 minus 20 over this, and then I would have gotten equals 3 over s squared. And I didn't, and well, this one, I just assumed that it would equal the magnitude for some reason, and it didn't because I thought I was solving for acceleration really, when I should have been using a different equation more related to friction, which would be these ones. Yeah, these 2 would be 0, while the bottom one, the 50 newtons, the applied force, would be 3 instead.